Hi guys, so today what we're going to be doing is we're going to go through 2-1-B, visualizing the graph of the derivative. So yesterday what we talked about was what does it mean for something to be a derivative? And we said that a derivative is basically the slope of a tangent line. So we're going to kind of skip the warm-up for today. I'm just going to kind of remind you what that is. So if I have some graph and we call it f of x, we would say that f prime of x is going to be the slope. F prime of x represents the slope at any given moment of f of x. So it's the slope anywhere. It's the slope anywhere on f of x. We define it using a limit notation for now. The limit that we use to define a derivative is this. The limit as h approaches 0 of f of x plus h minus f of x all over h. And we're going to be using that today. All right, let's go ahead and practice. So for this first one, find the following tangent line. Best thing we can do for this problem is draw a picture. It says find the equation of the line that is tangent. Ooh, when I hear the word tangent in calculus class, I'm going to write the word derivative because it doesn't hurt. That is tangent to the graph of x cubed minus 4 and parallel to y minus 3x plus 5. I'm going to draw a picture for a minute. Okay, so here's my picture. My picture looks like this. I have a cubic function that's been shifted down 4, and you guys are responsible for knowing how to graph parent functions, so if you don't know how to do this, you should. Okay, so this is my parent function here, x cubed minus 4. And in fact, actually, I literally just redid this lesson because of this. Can we please change this to x squared minus 4? Okay, that's going to make my life a lot easier. Let's do it. All right, so we have x squared minus 4. Which looks like this. Doesn't look like that. Looks like this. Okay. So x squared minus 4 is a quadratic. It's asking, find the equation of the line that is tangent to the graph at y minus 3x plus 5 equals 0. So what we're looking for is we want to find a tangent line that is parallel to this line here. Okay, well, this line here, if I solve for it, is this. It's y is equal to 3x minus 5, which means the slope is 3. So let me go ahead and graph that on here too. So I have 3x minus 5, which maybe looks like, I don't know, make a steep slope. That's not very steep. Could have been steeper. Okay, like this. So what I'm looking for is I'm looking for an equation of a line that's tangent to the graph x squared minus 4, which means it touches it once, and it's parallel to this line. And that probably is going to happen 2 times on this graph. So I'm going to guess where that happens. In fact, actually, I think it might only happen once, so that's lovely. So this is my guess of where it happens, okay? This is what I'm looking for. So in order to find the equation of the red line, I need to know a slope, and I need to know a point. So here's what I ask you guys to please do when you're in AP Calculus with me is this. Anytime you're asked to find the equation of a line, I would love if you guys could do this just for me. Do this just for your calc teacher who works very hard for you. 1, I want you to write that in order to graph a line or in order to have a line, you need a slope. Another thing that I want you to write is that you need a point. Okay. You only need 2 things to answer this question. You need a slope and you need a point. Anytime you're asked to find the equation of a line, you need a slope and a point. Thankfully for us, we have half of the answer. If my slope is parallel to the other line, so if I want this red line and I know that the parallel line has a slope of 3, I'm halfway done. The slope must be 3. So now what I'm looking for is the point. And the point's going to be a little harder to find. In essence, what I want to know is at what point does this quadratic function have a slope of 3? When does the quadratic function have a certain slope? That's interesting. That actually reminds me of what we just talked about. F prime, the derivative function, is the slope of anywhere on f of x. So anywhere also includes 3 as a slope. So if I can find the equation of all of the slopes of the entire quadratic function and set it equal to when that slope is equal to 3, I should find the exact point when the slope is equal to 3. So I'm going to find the generic equation for all of the slopes of this quadratic by taking the derivative. So I'm going to take the derivative of x squared minus 4. To do that, I'm going to use limit notation. It's going to be the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, f of x plus h, that is some simple substitution there. I'm going to plug in x plus h, into x. So this is going to be the limit as h approaches 0 of, instead of saying x squared minus 4, I'm going to say parentheses squared minus 4, and I'm going to put x plus h in. And then, be careful here, I'm going to subtract the whole function f of x, which is parentheses x squared minus 4. All I need to do now is do some algebra and solve. So I'm going to go ahead and pause this. You guys can pause too. I don't want to waste your time. I want you to solve this. Okay, so with a little bit of algebra, you should end up with 2x. So 2x represents the slope at any given moment of this quadratic function. So my question is, when does the quadratic have a slope of 3? That's going to be the point that we're looking for. Well, the quadratic has a slope of 3 when 3, my slope, is equal to my derivative graph, when 3 is equal to 2x. I'm going to divide by 3, and so I get x is equal to 2 over 3. That is half of my point here, 2 over 3. Okay, to find my other point, I'm going to plug it back into the function. So I'm going to go ahead and do that there. In order to find the other point, I'm just going to plug in f of 2 over 3. So f of 2 over 3 is going to be 2 over 3 squared minus 4. So what you're going to end up getting there is going to be about 32 over 9, which I don't have this here. Negative 32 over 9, which is like negative 3.5 rep per 10. Okay, so our other point here is going to be negative 32 over 9. Very last thing that we need to do here is just write an equation. Writing an equation is so easy, especially if you know point-slope form. Point-slope form is my absolute favorite form for AP Calculus because it is so easy. All you need to do is do this. Y minus y sub 1 is equal to m times x minus x sub 1. And then just plug in what we know. Well, I know y sub 1, a y value would be negative 32 over 9, so I'll say plus 32 over 9. Is equal to m, which is 3, times x minus 2 over 3. And that's it. That is an equation of a tangent line that is parallel to y minus 3x plus 5 equals 0 and has a tangent line on x squared minus 4. Okay, so I know that was a lot of work for that one, but this question pops up a lot of times, usually in a little bit of an easier manner. So there you go. All right, let's keep on moving. All right, next question, visualizing graphs of derivatives. So this is the goal for the whole day. So sorry, Sadie, that I forgot, but the goal for the day is to visualize derivatives. So oops. We want to graph the following on the same axis, okay? First thing I'm going to graph is negative 5x, and I'm going to graph negative 5x. Let's do it in blue. So to do this, it's going to go through the origin. It's going to have a slope of negative 5. So 1, 2, 3, 4, 5. Slope like this, and it should look something like this. Let me see if I can continue that on. Okay, so this blue line has a slope of negative 5 always. So we could use the limit definition of the derivative to take the derivative and find f prime of x, or we could ask ourselves this question. Here's the question. What is the slope of f of x? What's the slope of f of x? Well, the slope of f of x is always negative 5. We can see that on the picture. And so f of x has got to equal negative 5 always. And I'm going to graph that. 1, 2, 3, 4, 5. We're going to create a horizontal line here at negative 5. Because the slope of a linear function, negative 5x, is always negative 5, we can actually say that the derivative of negative 5x is actually negative 5. In fact, we can actually make a general rule for it. If I have f of x is equal to kx, then f prime of x is always going to be equal to k. So in essence, a constant times a variable, the derivative of that will always be the constant, which makes sense. A linear function always has the same slope, and thus, if I took the derivative or found the slope of a linear function, it would always have the same slope. It would be constant. It would be a horizontal line. So the derivative of a linear function is a horizontal line. Let's talk about x squared here for a minute. X squared looks like this, roughly looks like this. Its derivative is going to be, its derivative right here is going to be 2x. So pause for a minute, see if you can figure out y to be 2x. You can either use the limit definition of the derivative, or you can use a rule that you might have learned earlier. Okay, so by taking the derivative here, using the limit notation, which I kind of skipped around for you guys, what we're going to end up getting is the limit as h approaches 0 of 2. The limit as h approaches 0 of 2 is equal to 2 because the limit of a constant is a constant, and that's just a rule of limits we learned earlier. You can actually address that if you were to graph 2. What's the limit as x approaches anything? If I have a horizontal line of 2, the answer is always 2. So we can see here sorry guys, I took the derivative of the wrong thing and I cannot go back to edit. So I'm going to start this over, forget what I said about that first derivative. I took the derivative of 2x for some reason. Let's take the derivative of x squared. So I'm actually going to walk you through this. We'll start at the beginning, then we'll pause. All right, so what you can see here is that after taking the limit, what we're going to get is 2x as the generic derivative of x to the second, which means that the black parabola right here, its derivative function is a linear function, which looks something like this. So its derivative is a linear function. So you might start to see a little bit of a pattern here, and if you don't, I'm going to point it out to you. Notice here how when I start off with a linear function and I take the derivative, I get a horizontal function. When I start off with a quadratic function, I end up with a linear function. So notice how I'm power reducing. If I start off with squared and I take the derivative, I end up with being to the first power. If I start off with the first power here and I take the derivative, I end up with x to the 0 power, which is 1. So just kind of take note of that. We're going to learn some more rules of derivatives later, but let's keep moving. Next question, on the same axis, draw the graph of the derivative. I'm going to do the first one with you. To draw the graph of the derivative, all we need to do is estimate what's the slope at each moment. So let's start at the point 0, -2. I estimate that the slope at this moment, I don't know, that slope looks like it's got a slope of 2. So I'm going to say that the slope at that moment at 0 is 2. Let's go on to 1. The slope at 1, if I draw a little tangent line, looks like, I don't know, looks like a half almost. So I'm going to go down to a half here. So at 1, the slope is a half. At 2, if I draw a little tangent line, the slope is 0. So I'm going to be down at 0 here. At 3, the slope looks like it's about a half. So I'm going to come down to a half here. And at 4, the slope looks like, I don't know, looks like it's 2. So I'm going to put my point here at 2. I'm going to connect these. Interesting. So I get a quadratic here. Notice how the original purple function was a cubic. And when I took the derivative, I got a quadratic. So remember that. When you start off in 1 power and you take the derivative, you should power reduce 1 exponent lower. Let's try the next one. All right, so the derivative at 0, 2, if I draw a line here, is 0. There is no slope there. The slope there is flat, it's 0. The slope at 1 is also 0. The slope at 2 is also 0. The slope at 3, if I were to draw a little slope line, looks like maybe a slope of 1. And the slope at 4 looks steeper, maybe a slope of 2. Interesting. Kind of looks the same. We'll talk more about this function here. This one is actually the e to the x function, and believe it or not, the derivative of the e to the x function is the exact same thing as e to the x, which is really interesting. We'll talk more about it later. Last one, finding the tangent line at a point. For a function h, we are given that h of -4 is 7. That's a point. That's probably good to know. -4, 7. And that h prime of -4 is 1. That sounds like a slope to me. Remember that derivative means slope. Find the equation of a tangent line for the graph at x is equal to -4. Okay, whenever a question in AP Calc asks you, could you find the equation of the tangent line? Think of your dear sweet calc teacher. I ask you one thing, just do one thing for me. When you see the word tangent line, when you're asked to find the equation of a tangent line, I'm going to circle the word line. And under the word line, I'm going to write that I need two things. In order to have a line, I need a slope and I need a point. So as my calculus students, you guys, when you guys see the word equation of a tangent line, I want you to circle the word line and write the two things that you need for a line, a slope and a point. Thankfully for us, they told us the slope. They told us that in a calculus way. They said h prime of -4 is 1, but I know that h prime represents a slope. And so my slope here is 1, and my point here is -4, 7. This is the easiest problem ever, and yes, this does appear on the AP test, which is so crazy because it's so easy. If I'm going to write the equation of a line, I need a slope and a point, and I'm going to write it in slope-intercept form because it's so easy. So I'm going to go and do that. Not slope-intercept form, point-slope form. I love point-slope form. So here's point-slope form. Y minus y sub 1 is equal to m times x minus x sub 1. So easy. All I need to do is plug in the point. Y minus 7 is equal to slope, which is m, times x minus -4, which is plus 4. In AP world, you can literally leave it like that, and that is good enough. How awesome is that? Easiest question ever, and I hope all of us do not miss it because it really is as easy as writing a slope and a point. All right, last question. Oh, we're done actually. All right, so that is it for 2-1B. I will see you in a little bit for 2-1C.